Hello, everyone. My name is Tiburcio Asua Jr. My friends call me Tibu. So basically, I'm just going to talk about my project I did for Architecture 461P. It's on shading, and so I really just wanted to kind of explain my project and really see how this is beneficial to our built environment. So huge shout out to my professor Omar Youssef, great guy, a lot of key insights and really helpful in acknowledging your design ideas. So let's get right into it, module 3. So this was part of the class, last week's inspiration. So basically there's these towers, Al Bar Towers in Abu Dhabi City, UAE. And they have something that they're calling responsive shading, which is basically shading that is responsive to different seasons, time of the day, things like that. And so I really liked the ability to control this type of shading for privacy, for just again manipulating daylight and heat and all that. So basically the bottom line was motion as a mechanism. I really thought that was going to be important in my own implementation of a design. So these were my goals, independent of the assignment. Number one was to build with nature. I really tried to see if I could improve the ecology in the surrounding environment. Number two, cost-effective design and materials. I really wanted this to be as simple as possible. And then number three, responsive shading, taking that inspiration and then kind of manipulating it to be both passive and active. So this is what I came up with. Materials. I wanted, of course, the best heat resistance, and they must be cost effective. So this is a lecture slide from my class. And so basically the first thing I noticed was the lowest surface temperature was on green, grass and trees. So this totally makes sense. These materials are acclimated to the direct harsh radiation. And so I knew I wanted to incorporate them in my design. Next, glass. It's the second best temperature, and it also is fairly readily available. The third best temperature, wood or CMU, concrete masonry unit, pretty standard stuff. You can find that at your local hardware store. So then the shade materials, I decided to use a desert vine for various reasons, but essentially there's a very specific kind called Halls or Cape honeysuckle, and this is of South African descent, tolerates really hot weather, poor soil, and basically the key points are minimal watering and should be cut back in winter. Now that's going to play a really key role in my own design, which I'm going to talk about later. Also, an added benefit relating to my first goal is that flowers, you will see them in the spring and in the summer. So of course, this helps pollinators and really just improves the natural environment surrounding the building. These shade materials, glass, I decided to create this really interesting combo of tempered wired glass for safety. So tempered means that if the glass shatters, it will be small pieces, not these large chunks that are more risky. And then the second pane is going to include frost. So basically this kind of just reduces sunlight and allows less light to enter the space. Together, these two panes will create a very unique glass combination. And so this should reduce heat, and this also should reduce even more light transmittance. Also, I think glass is really durable because it's very easy to clean. So of course, the moment you shatter it, it's basically useless. But till that moment, it's fairly easy to maintain. So these were my rough sketches going into the entire assignment. Basically, this is a side profile of a window. And this was kind of just my idea of incorporating some sort of just a planter box with some glass. You can see the planter box here and the glass up top. So basically the idea was just to really try to cover the window most efficiently as possible. And so this is a top view. This is a view of the glass, my original design, but I quickly realized that design was going to be very difficult to actually produce. Let me remove these. And then so now let's look at the south-facing window. This is one of the 2 windows for the entire project. So I decided to make mine out of CMU at first, just because this is probably the most easiest option if your building already exists. So basically fill it up with some concrete. You know, you're basically just building a planter box. This is how I came up with my angle for my window. Pretty straightforward. So yeah, this is kind of what I was left with. Like I said, obviously structurally this is maybe just conceptually okay, but this of course can be reinforced. This can be bigger, wider, taller, depending really on the window, on a lot of other key aspects. So then this is a second version here. This window was made using wood, so much more refined, a little bit smaller as well. The glass is the same. And then here I'm showing you kind of the direction and the rays of light that you will expect to see in the summer. It's about 70 degrees here. And then these 2 images on the right are just showing you what this vine could potentially look like in the summer when it's fully grown. These are my results. Basically in the summer when the vine is fully grown, you should see a good amount of shade in the space. So this of course is introducing diffused daylight, and ultimately very beneficial for hot arid environments like this project was placed at. This is my results for basically the winter. You're supposed to cut back that vine, so now suddenly you can introduce more light into the space depending on the season and things like that. So that's what I'm calling passive seasonal shading. I'm going to talk a little bit more about the same window, the south facing. So basically the idea is quite simple. In the winter, we have less sunlight, less vine, which means less vine equals more daylight. So essentially here you can see that by cutting back the vine, you allow more of the glass to be introduced. And because it is frosted, because there's also a lower percentage in transmittance, this will introduce diffused light into the space, which could help warm the space just because this is being done passively through solar design. Next, we have the summer. So in the summer, we have more sunlight, which means more vine. More vine equals more shade. So in the summer, we obviously want more shade because that's going to keep our space cooler. And so in the summer, another thing to consider is the angle of the sun rays. And so you can kind of just see here that there's less light entering the window, therefore there's less heat entering the window. So then now this is the second window. It's a west facing window, and I did have a little bit more trouble with this window just because there's a really interesting angle that you have to try to hit in the late afternoons, especially in the summer. So basically I started off kind of the same as the previous one. This was my first attempt. I played around with this swivel door because I really wanted to use motion as a mechanism to kind of just deflect shade. So this is finally what I came up with. It's basically the first design along with this swivel pane glass. And yeah, so this is here what it would look like with just glass. So now this is what I'm calling the active seasonal shading. This is something that can be done every day, every couple of weeks, even every season, as I'll explain. So again, this is the west facing window, but in the summer, that's why the vine is very long. And so ideally you would want to push your glass pane towards the wall. So you really want to make sure that the vine has a lot of clutter You want to make sure the vine kind of collapses towards itself, and this will create more shade. So as you can see here on the image on the right, there's this really interesting effect, which is called mashrabiyya. It's a Middle Eastern shading principle that allows diffuse light to enter. So I thought this was really interesting because it's a natural version of that. And this is in June. So as you can see, very effective in the summer sun. Next up is the west facing window. So this is an image on the right, what the shade would look like if you do not trim the vine in the fall to winter. However, because it is winter, we want more sunlight entering the space to warm it up, free from the sun, of course. So I propose that you do trim it back. And this will, of course, allow plenty of light to flood the space and warming up the interior. Depending on the room, depending on the face of the window against the sun, you may or may not want this much sunlight entering the space. And so basically this design allows for adaptability. If that room does not require that much sunlight, perfect, you leave the vine much longer. This is another feature that I thought of when it comes to the active seasonal shading, is that if you were to take this glass pane and extend it outward, you would essentially create a slit between both panes. And so this directly allows more sunlight to enter, even in the coldest winters. As you can see here, September 23rd, so right around, you know, almost fall. And so pretty effective. This is something, of course, this window pane can be adjusted in the mornings every day. Perhaps you do want plenty of sunlight in the summer. You never know. This combination allows such possibilities. So then this is kind of what the two designs look like on the final building. This is the entire structure itself. And so you can see here again on the right side, plenty of shade on the window, but also on the wall. So this is something that, of course, you know, bigger planter box, bigger vine. This vine can grow upward onto the walls, onto maybe the roof. And this, of course, will provide more of a buffer zone between your wall envelope and your vine. And so this little air buffer zone will essentially allow the building to remain much cooler. So in the desert environment, that could be very important. My final thoughts on this idea that I came up with is that, yes, responsive shading is an awesome feature because it allows you to adapt and adjust your daylight depending on the seasons, time of the day, and things like that, both in the active and the passive, also in the micro, which could be the day-to-day, but also the macro, which could be the season to season. So it gives you a lot of flexibility with light. Next, that pro feature, which is the mashrabiyya, which I mentioned on earlier. You can kind of see here on the right image. Basically, this is an effective way to reduce the amount of sunlight entering the space. This ensure just creates more diffused daylight. And so this could be an effective design idea for just reducing heat gain in the south-facing window. Again, another pro, pollinators. I thought just because these vines can produce flowers in the summer and spring would be great for the aesthetics, but also for the environment. Perhaps this is in a community, in a neighborhood, and having more pollinators could be beneficial to the trees, to crops potentially. So that was always an added benefit, is to try to improve the nature and the surrounding environment of a structure. The two cons, of course, the first con is maintenance. This is something that you will have to address. It's a living vine, and so it will get very big. It's well acclimated to the desert, so before you know it, it may be very huge and you may need to trim it back. Regardless, any other material that you would have used, such as metal, wood, stucco, these materials also require some sort of yearly maintenance, whether it be cleaning or refinishing. And so I thought the vine, you know, isn't really that much maintenance, just because you have to trim it back once in the winter. The next con, water. I feel that maybe this vine will require a good amount of water for the first year or so, but after the vine is well adapted and acclimated to the environment, it should require very little water. This type of vine is just as adapted as saguaro cacti are in Arizona, and so because of their surface area, they're able to generate more energy through solar heat gain than through water. That's why these foliages are very, acclimated to the desert and to the heat. So yeah, that's basically the entire design. One is for the south, one is for the west, which could also be applied for the east. Overall, I think it was just a really awesome lesson, because we got to really explore the challenges of solar geometry, which is basically just the angle and direction of the sun. And I really got to push kind of my limit on what I think is aesthetically pleasing, but also functional. So yeah, overall, that's going to be the final thoughts of this video. Thanks for watching. If you have any questions, comments, concerns, please check out the links in my bio. I talk about sustainability and really just how we can improve our building methods in the fight against global climate change. So yeah, thank you. Tibu signing out.